Welcome to ClickMyProject.com. Let me discuss about the process enhancing security and privacy for identity-based batch verification scheme in VANET. Let me discuss about the abstract of the project. Most VANET applications are built upon the data push communication model, where information is discriminated to a set of vehicles. In vehicular ad hoc networks, that is VANETs, vehicles transmit traffic and safety related information, including traffic congestion, avoidance messages, accident warnings and accident reports, etc., which assist drivers in making proper decisions to avoid vehicle collisions and congestion. Vehicular ad hoc networks are created by applying the principles of mobile ad hoc networks, that is VANET, the spontaneous creation of a wireless network for a data exchange to the domain of vehicles. They are a key component of intelligent transportation systems, that is ITS, as VANET exhibits several unique features such as a high mobility of nodes, short connection times, etc. Conventional security mechanisms are not always effective. Consequently, a wide variety of research contributions have been recently presented to cope with intrinsic characteristics of vehicular communication. To enhance the efficiency of verification, a new ID-based signature scheme is proposed that allows batch verification of multiple signatures to mitigate gang injection of false attack thread. It allows any pair of users to communicate securely and to verify each other's signature without exchanging public key certificates. With the advent of digital signatures has come the need for verification signatures, but the human thirst for warning and power never comes to an end. Let me discuss about the flow diagram for our process. Initially, the parameter initialization based on IA. It generates two groups of order. Let be a bilinear map. Let the denote two generators. TA randomly selects a number of calculates whereas a private key and a public key. TA chooses two hash functions for the first generation of each vehicle. TA assigns a real identity and password. TA then preloads into the vehicle tamper-proof device. TA announces the public parameters to all RSUs and vehicles. Next, identity-based verification scheme have been proposed. When an RSU or vehicle gets the final message from near vehicles, RSU or vehicle checks the signatures of messages to ensure that the corresponding vehicles are not trying to disseminate false messages. On the other hand, a large number of messages may congest in an RSU at the same period in some situations. In order to reduce the bottleneck problem, we introduce the batch verification. Many signatures can be verified at the same time to improve the signature verification speed, which can achieve much better scalability. Single verification of one message given the final message sent by the RSU uses a public known system parameters assigned by a TA to execute steps as follows. RSU considers the freshness of the final message to withstand with replacing attack. Assume that the receiving time RSU computes whether is correct. If it is true, then RSU continues. Otherwise, RSU rejects the final message. RSU verifies the signature by checking whether holds or not. Assume that RSU just receives a few messages. It can check the message authenticity during the above operation one by one. Batch verification of multiple messages. Consider how much batch verification can be done. When RSU needs to check a set of final messages, assume that RSU receives distinct final messages denoted as sent from. It can confirm final messages authenticity simultaneously by batch verification of multiple messages. Finally, the performance has been analyzed. Estimation of time for execution, signaling, verification and average message. For each performance metrics, delay has been estimated. Let me discuss about the running procedure for our process. Select the main.temp file in the current folder, right-click the file and run for executing this process. And this will take much time for execution of this process. Here the VANET applications are implemented. Here the securely data has been transmitted in VANET, and finally the identity are verified based on the identity verification based scheme. After that we can compare the result with existing methods. After execution process, here the computation delay, that is our proposed method for performing signing and verifying process, and this is the signing delay between our proposed and existing method for execution of signing process, and this is the verification delay for our proposed and existing methods. Here the time has been estimated for performing verification process, and this is the verification delay by varying the number of messages compared with existing and our proposed system. This is the transmission overhead, that is data has been transmitted by varying the number of messages and compare with existing and our proposed system. This is the transmission overhead by varying the number of messages compare with existing and our proposed system. This is the average message loss, that is packet loss. Once the packet will be received, we have to estimate the losses of the packets that will be performed by varying the number of vehicles, and the result will be compared with existing and our proposed system. This is the average message loss ratio for varying the number of vehicles and between our existing and our proposed system. So for finally we have achieved the good performance compared with our existing system in the terms of delay, verification delay, signing delay, and average message loss ratio. Thank you.